So I guess one quick item, and I'll probably circle back to this if there's more folks who pop in later. Wanted to check and see if the SimPEG governance meeting conversation tomorrow, if that works for folks at 11 a.m. Pacific. I got there's a few thumbs ups on Slack, just a question of like, is there anyone who it doesn't work for, who wants to be there? Okay, it looks like mostly thumbs up. So let's plan for that. And I will send out a calendar entry with a Zoom link, and we can go from there. And I'll try and send up like a couple sort of agenda items with that too, to give us a bit of structure. Cool. Okay, who wants to kick things off?
I can go first.
Perfect.
So I've been, yeah. So I started a PR on Discretize that shows, that's a kind of my first pass at removing properties from Discretize, the properties package, just to be able to have a little bit more control over the documentation. Like that's a primary motivation, as well as it's not super reliant on it anyway. So it's an easier ask to be able to remove it from that so we can control the documentation. There's a few small little things in there that I need to catch, a few small little bugs that are still there, mostly with how you can't, so some of the properties on meshes are like NumPy arrays, and you can't serialize a NumPy array directly, or at least do a JSON to JSON directly. So there's a few catches like that. Also, I have been doing work to play around with the PyData theme for the NumPy, or for the documentation on Discretize. So I'd like to show that really quick if I can.
Absolutely.
To kind of get, I showed a little screenshot before on Slack, but I'll share this really quick. So this is kind of what I was thinking the PyData theme was looking like. There's a few things that I'd like to change around here still. I'm not quite sure yet how to switch the Twitter icon to be like a black or a grayscale one. I'd like to make up a grayscale image of the SimPEG logo with Discretize next to it, just to be able to have it on there as well, because grayscale looks better on this background. But if you notice, the formatting and like the kind of font and color scale looks very similar. That's SimPEG.xyz. So that was kind of like one of my reasons for at least choosing this color scale, was to make it more consistent. Like the header fonts are the same, especially in that header font is the same font as this font. It's going around. Instead of them all being on the side, and I can go to the current Discretize docs to get a change. So this is what it looks like now, as opposed to something like this. In my opinion, I think it looks a little bit cleaner. If everyone is on board with this, it's probably a good thing. Or at least I would feel more confident if other people agreed with me, but this is just my opinion.
I think it looks beautiful.
I just particularly like that it looks similar as the SimPEG.xyz format website.
Yeah, it's really clean, man, and it looks quite modern, right? It's a aired out space. It's not too cluttered with a bunch of banners and stuff. So
yeah,
I really like it.
It's really interesting, like how it works as you're scrolling through things. So if you look up over on the right hand side, as I'm scrolling through this list, it's updating itself where it's at. This is just kind of the tree that we would normally see. There's still a few things that I'd like to get around with this. And I'm kind of thinking about where the mix-in class is imported.
Can you go in one more level, Joe? Can you go click on base mesh? Yeah.
This one? Yeah. So base mesh, I've gone and kind of updated a little bit of the internal documentation on it to look more NumPy-like, or to get NumPy-style documentation for the base mesh, as an example.
That's beauty. So they all cross-ref, like shape cell is going to switch to.
So yeah, now, so this is what this documentation looks like for this. They all cross-ref, and there's not a big list at the end of the page anymore.
That's great.
And all of the classes are on their own page, and these will all link to another page.
Beauty.
Yeah, just
what's
a little bit cleaner.
Joe, what's the role on the right, like a right-hand panel?
This panel?
Yeah.
It doesn't, it's a like a table of contents scroller, so you only really see it in sometimes, so when you're over here in this function. So this is, as you're scrolling through, it tells you where you're at in the RST document, basically. It doesn't work very well, it doesn't really pop up in the NumPy doc generated things. So this page was generated by like an auto summary, an auto generate. I would like to remove this on these pages because it doesn't link to anything, because this would edit this page on GitHub, but this page doesn't exist on GitHub because it's an auto-generated page. I'd like to leave it on the pages that it could work. So, right, it kind of works already. I've moved a few things around, which is why some of the links are a little bit broken. But in my opinion, it just looks cleaner. There's a few things, like I said, that came up as I was talking about this. One was, I don't think we should, I want to change where we're inheriting the mix-in classes. So it kind of doesn't make sense for them to live on the base mesh because they're not valid on the base mesh. They're only valid on like tensor, tree, curvilinear meshes. So it kind of makes sense to just import it or have it be a dependency on those classes. At least that's kind of my opinion on some of those things. And then we're still trying to figure out a great spot for this mesh IO routine to live. And right now it's in the base folder, but it doesn't have to be there. And it's basically what handles the UBC IO.
So the VTK one is not in there. Is that right?
That's handled. No, that's handled in the VTK mix-in now.
Oh, I see.
Would it make sense to have like a UBC mix-in?
I was thinking about that. It's just leaving it in there and then always having it, like it'll always be available.
Yeah,
because that'll make it a little bit clearer, like, oh, this is UBC IO instead of anything else. There was a load mesh function in there that I've already moved into the utilities because it kind of made more sense as a utility. That's about it. Other than that, you can't see because she is quarantining, but my wife is in there.
Joe, that's wonderful news.
Yeah, that's great, man. Finally. She's quarantined from you?
Yeah.
No way.
Yep.
That's funny. You guys are by the book.
For 2 weeks.
You just like push food in the tray in the room?
Oh, so she's not gonna go out from that room. I see.
Well, I mean, she can't. She does if she has a mask on. Sometimes, if she needs something, she'll put a mask on and come out and go do what she needs to do. But she's here. I picked her up yesterday from the border.
How serious like this government actually checking that, and like they call and then sometimes come by and check if she's there?
We'll find out. But when she crossed, they're like, yeah, you could face up to 3 years in jail or $1 million fine if you're like caught, not quarantining or something, if you're caught out. So they've seriously upped the fine in time.
Yeah, but at least the fines are in Canadian dollars, Joe.
That's not going to be, either way, it's not going to help me.
So,
Okay. That's all I got.
Excellent. Well, that's really exciting news, Joe. I'm so pleased she's made it, and she'll be done quarantining by Christmas. So that's excellent. Perfect. I see Dom next on my screen. Dom, would you be willing to go next?
Yeah, I don't have anything to report this week.
Okay. Fair enough. John.
5 minutes. Got some action in the background.
Oh yeah, sure, no problem. Thibaut.
Yeah. Hello, everyone. Just one thing, not SimPEG related, to start with. I've finally updated the UBC GIF website for publication, thesis, and a portion of the proceedings with presentation. So if you want to check if I didn't forget your publication, or that if you want to send me a presentation that you gave and I can put that on the proceedings, just let me know. But yes, the UBC GIF website had not been updated since 2017, so there was quite a few publications to add.
Thanks very much for doing that, Thibaut. That's great.
But yeah, I might have forgot one or two, a few. Let me know. I put everything I was aware of, but I don't guarantee there is no omission. More on SimPEG. I've added yet another PR to the pile. This one is I've actually added like a tutorials for a joint grav and mag inversion with petrophysical coupling and on an octree mesh. And there is 2 inversion in that. Like I discussed with Devon, we might separate that in 2 tutorials. And one is like when you provide petrophysical information, and the other one is when you don't have prior petrophysical information, and how you use both, how you can do that with the code. And it's actually fairly fast. So it's like both inversion together takes 6 minutes on my laptop to run. So that's so I'm happy with the result, and it's again like the synthetic TKC, but yeah, so like it's close to the publication too, so that's gonna be useful. And other than that, working to get all my other PRs moving forward. So Joe has been helping me a lot, starting with moving the beta estimate one. So one thing for everyone too is like I've checked all the examples and tutorial and updated the beta estimate values so that it's very similar to what was there before. So, so like this, updating that directive should not change drastically what the examples I was already in there. That's
excellent. Have you had a chance to connect with Xiaolong on that? Because Xiaolong, I think your pull request also needed to touch the beta estimator. Is that right?
Yes.
Yeah, Thibaut, would you mind maybe connecting with Xiaolong and just pointing him to sort of like what sorts of things you changed, so that we can kind of think through how to, because I suspect that the solution that we needed for either scenario, for either of your work, should serve the other. So just kind of making sure that what's been done on your pull request hopefully serves his pull request.
Well, from what I remember looking through the cross gradient pull request, I saw that directive, and it was basically using the same the same thing as the previous beta estimate. So in my opinion, it will need to be updated to at least like use that new eigenvalue utilities. That would be the first step. And after that, we can see. I'm not sure. Yeah, I'm not. I don't remember what was the big difference. So after that, I think when we work through the cross gradient pull request C, what can what can we merge with other directives, or how to create a new directive. It really depends on, I guess, on how we formulate the inverse problem and what we consider as a trade-off parameters or alpha scaling. So I think that was the main difference. But yeah, like just as of now, what I remember is that it was very close to the former formulation. So updating it to use the new utility will be a first step.
Yes, so in terms of maybe a bit of a suggestion is how to make that a bit concrete. And Joe, feel free to jump in if you've got other thoughts on this too. But Thibaut, when you're happy with the beta estimate pull request, would it be possible to maybe start a pull request onto Xiaolong's work to show or like start to work towards bringing just that one piece a little closer together? Would that make sense as sort of a next step? Maybe not.
Yeah, I think that would be a good idea. I'm just looking through it again, Xiaolong's full PR on there as well right now, again, just to remind myself. It does touch a lot on the directives. I think there's a few things that are commented out that probably shouldn't, it looked like they were changes that were meant for your local stuff on there that were like just bracketed, commented out, that probably should be looked at again. But I don't think it'll be too much of an issue merging them.
Yeah, and at least to me, this seemed like a good sort of first step, because at least this one is well scoped. So even if there's other stuff that was commented out and things like that need to be resolved later, at least like getting onto sort of a common beta estimator is perhaps a good step forward in bringing those works closer together.
Yeah, I would agree.
Hey, just a quick comment. Thibaut, great. It looks really, really good results. It's pretty amazing. I have one question, I guess, related to this for Joe or Lindsay. Is it possible to still have those tutorials, built from a PI file, but just try to move all the plotting functions out of it or somehow hide it? Because right now, like this, those tutorials, they look super long, but there's so much of it is just plotting functions, just unrelated to what we want to talk about. I don't know if it's possible to somehow hide those. And that's true for Thibaut's like a tutorial, but all of them, they have like so many like lines of plugins.
Yeah, I mean, some of it is just being a bit clever and finding ways to kind of compress it or write the code more compactly. Another thing that can be done is with the way that you comment it, you can partition out the parts of that PI file into subsections in the website. So you can put a heading that's like, all right, we're plotting this now. This next chunk is plotting, and you can just skip if you want to. So we don't necessarily have to take it out, but we can do some, let's say, tricks to have it render on the website in a way that partitions things nicely.
Or to not show, if it's possible to not show those chunks, right? Because we don't really need to show them.
Yeah, it's true. I find it sort of useful to see some of, you don't want to have like 80% of the PI file being
it's completely unnecessary
utilities. And if we are reusing some stuff, we might be able to just add that plot style into plotting utilities. That might be a better solution. But I find it kind of useful to be able to go and see how certain plots were were generated.
If people are that interested, they can go and like download the file and look at the file, right? But to me, it kind of clutters the read. If you're trying to teach people how to do something, and now you have like a block of like 50 lines of scripting for plots.
One thing that would be worth looking into is I suspect we are not the only ones who have encountered this problem. I would not be surprised if there's an extension or some sort of flag that we can use in that like Sphinx gallery or sort of in that auto documentation. I would not be surprised if somebody's written something to like collapse.
I was gonna just.
What I think would be great is, you know, if you collapse and then you can just hit a button that like unpacks all of that code if you really do want to see it. But I don't know if that exists, but I suspect it exists.
I was just
That would actually be awesome. Well, that would be super awesome too, because the way it generates on the website, you'd have some kind of heading or subheading. You would have text that gets generated there, and then usually below you have the portion of code, however long it is. And if you just had a button to expand, that would actually really, really shorten those pages. That would be pretty sweet.
But yeah, I agree with you, Dom. It was one of my concerns writing the tutorial, because like, for example, when I want to plot the Gaussian mixtures probability distribution, we don't have any utils for that. So I end up with having like a lot of lines to trying to plot that. And I put some concern right now to like try to have it compact, but yeah, it's true that it's very long. And one quick solution I can see right now would be like, I already download like the mesh and the data, etc. So it's not in there. I can probably imagine that we can download like a .py file and then add it to your path and have utilities in that Python file that you download. That could be one option too. I could try that this afternoon and see what people think of that as a quick solution, if that sounds good to people.
Soggy just posted a link that I think is worth checking out. And Joe, I don't know if you've actually seen any solutions like this, but I think with this, before we come up with sort of a complicated solution of like downloading Python files that just contain like a tiny utility, let's do a bit of a search on this. Because I'm sure somebody solved this problem. And so yeah, let's not invent something before we decide we need to.
Yeah, I'm just looking through that now. It looks pretty similar, as I've been working through CSS stuff and customization stuff for the documentation already. So.
Yeah, one thing that I'm not sure, like when you auto-generate the doc from the notebooks, that's I'm not sure how that's gonna work out, but yeah.
Excellent.
That's it for me.
Thanks, Thibaut. John, would you be game to go, or you want me to circle back?
No, I'm all good now. Sorry,
Okay.
guys. Yeah, nothing too much to report other than yeah, I've got the DCIP parallelized, the tiling parallelized, so it's doing similar to what Dom's got going, and I'm in the inversion part, so there's just a few little like, I think it's just some mismatches between dimensions. I'm getting there, so that should be running by next week or by the weekend, hopefully. Yeah, and I'm going to help out with the 2D MT and get into the CSA MT stuff. Yeah, I don't know if we want to include that in this PR, or should we maybe wrap up that first PR first and then make this something new? I'm open for suggestions. And also on the CSA MT side, dealing with the near field, how important is that? And yeah, how to tackle it, if anybody's got experience or or good recommendations.
Like what's the scope of CSAMT? Is that the 2D code? Are you doing a 2D code, or like?
Well, yeah, I was gonna help out with the 2D MT, so that because most of the applications that I guess the applications that have been tendered are mostly 2D CSAMT. So I thought getting the 2D MT up and going, and then should be after that we can incorporate the CSAMT receivers. Was the idea kind of thing?
I see.
Yeah. Yeah, Lindsay's kind of gotten me up to date. I've got I've got some reading to do, but yeah, we should be able to work out those boundary conditions for the 2D stuff. And yeah, I think that's what I'll aim for.
As far as like splitting off, I would say we should probably, let's get this MT pull request wrapped up.
Yeah. Okay.
The MT being wrapped up in scope.
Yeah, I'll focus on that first. Well, yeah, I'll start working on those tests and make sure everything's going and passing, and then yeah, get into the 2D stuff.
And John and I have gone back and forth a bit on a notebook, and on my list is to write out the 2D derivation. And so I know Sagi's done a notebook too. So between all of us, we can compare and hopefully get that running. I think it's really close right now. I was showing John yesterday. It's really close. Like we're getting the right apparent resistivity in the middle of the mesh, but near the boundaries, it's wrong. So, and it's also expanding. So I think we're missing a volume term or an integration term or something. And so I'll write down what we've done and send that around. And if we can get, a few sets of eyes on that, that might be helpful. So
yeah, I think the potential problem might be in the TM mode, Lindsay. T is like I think the natural boundary condition is fine, but that TM mode, you need to specify a certain boundary condition. It's like you have a charge buildup on site. So I think that Carey's paper sort of like illustrate how he handled that boundary condition.
For this one, we were trying to drive it entirely from boundary conditions, so not a primary secondary approach.
Oh, okay.
So I did specify the boundary conditions, but
gotcha.
did something wrong.
Something not quite there. But,
yeah, definitely also like to take a look at it and see what I can see.
We can send that around.
For sure.
On that note, for CSAMT, I don't know if anyone else has recommendations for papers that we should look at for that modeling. Nick Williams had asked a couple questions about kind of getting up and running. I mean, we haven't tested any of that or sort of tried that out with SimPEG, but if there's any implementation papers that are worth
but what's the scope? Like I thought, like you could basically use the 2DMT code if the source is far enough, then that's that's how typically people handle those data.
Yeah.
So I don't see like I mean, if the assumption is, as long as the assumption is hold, I don't really see other issues of just using the 2DMT code first. As the John mentioned, like once the near field comes in, you cannot really assume that as a boundary condition. You just need to put the source in to the mesh. Then like it is like a typical frequency domain EM problem. So you need to use the actual active source and then treat the data as an impedance. I think, I don't really see other sort of like a complexity in there.
We're talking with some of the geos in DS here who've done MT and stuff. They say that's kind of like what the toss up is they don't know when you're going to be near field and far field. Like you can assume all you want, but sometimes there's still like, I don't know. He said it's very hard to tell. So it's nice to have the near source, or sorry, the near field kind of derived to see what it does. But we're like the idea is to plan so that you can just, it's far field, just totally use that.
Right. Well, then put the source in.
Okay. Yeah. Fair enough. Yeah. Sure. That sounds like a nicer solution.
Yeah, I think all you need in that case is like adding a data type, like a different receiver in the current frequency domain code. So if you just need PD, that's all you need, I guess.
Fair enough.
Yeah, I would treat it like CSCM, just with magnetic receivers, I would have thought, or electric and magnetic receivers. Or is there a problem with that approach? I can't remember. I must have a bunch of paper because back in GeoChem, we did quite some testing and measurements with CSAMT.
One thing to sort of think about is how UBC, like a latest UBC code, does the projection. Because what's actually kind of nice in the way UBC code works, you don't need a magnetic field. So you can just use the electrical field to derive, like, because it just evaluate the voltages. So you don't need to actually, you don't need to store or compute the H from E. So you can directly project that from electrical field. So if like that projection is kind of cumbersome in the current frequency domain code, just use the electrical field and develop a projection from electrical field that can compute the voltages and then compute the ratio. I think it'll be useful and sort of like gives a little bit more better efficiency. So consider that.
If you want some background theory for that, I can point you to the theory section of this MT code. And it sort of explains how, in general, we simulate this.
Cool. Right on.
Excellent. Thanks, John. Mike.
I guess this week I've just been kind of looking at some gravity data, trying to figure out, basically, we have this airborne gravity data set, and we're trying to figure out how important kind of some of the terrain corrections are going to be since it was collected at a fairly high altitude. So we have some ground gravity data as well, and we're just kind of playing around with that and going to do some kind of upward continuation of that ground gravity data, which has already been terrain corrected, up to kind of the elevation of the airborne data set and see how those compare and try to get some idea of the impact that the topography is having. And I was also just thinking of doing some basic forward modeling with that airborne data set with kind of different size cells and different refinement rates on the topography to kind of see how that changed our forward model data. So just, yeah, I was talking to Dom yesterday and we were kind of working on putting together, I was just kind of using an example that he had run a long time ago to put together a kind of equivalent source solution for upward continuation of those fields. So just playing around with that on a 3D octree mesh, and then also going to try messing around with it on a kind of a quad tree mesh to see the difference in those two results and just kind of differences in efficiency and some things like that.
What kind of topographic relief is in the area?
I would say some of our maximum relief is probably like 1,500 to 2,000 meters. And the data was collected at about 6,500 meters. So there's probably like a maximum clearance of about 4.5 kilometers or so.
Well, I mean, I would say if the terrain correction is like super costly, I mean, it might not, but it's better probably just to do it.
Yeah, we're trying to figure some of those things out and just kind of get a handle on that. I was also talking with Dom about that and looking at the way that they had kind of done some of that with the data from, I think it was from Iran that Mason was working on.
Mm-hmm.
So we were trying to revive some of that and just kind of see what we could get going with that and what kind of results we could get.
Excellent. Thanks, Mike. Devin.
Sure. So if there's anyone who has, I guess, shorter updates, we could let them go first. I remember last week you guys asked me to maybe give you the 10-minute tour of the discretized theory sections. So I don't know if we want to get to anything else first or whether or not I should just sort of go for it.
Will it be sort of 10? Yeah, if it's going to be like 10 minutes, then yeah, let's continue around and we'll circle back if that's okay.
Yeah, sounds good.
Perfect. Thanks, Dev. Xiaolong.
Yeah, sure. I don't have anything to report this time, but for the new beta estimation method, I will check it to see whether I can use this part of the code. Here I have a question for the T-bot. So can the new method estimate the two beta values, say for one for gravity, one for magnetic at the same time?
Okay, so right now, like in that PR, I wrote like directives that's like that are like when you have like data misfits, can have one or several, and you have a regularization with alphas, so it and one beta. So I think what's different in your estimate is with your beta is that you have different beta for grav and mag, but the way it's written right now, there is actually now a utils in mat.utils where when you give it any objective function term, like a data misfit or regularization, it's going to output you an estimation of its eigenvalue. So what you can do, and so this type of ratio, you actually doing it right now within your directive. But I showed in that notebook that I put in the PR that when you do that estimation a single iteration, it's actually like it's not a very good estimator. So what you can do is that you can, within your directive, instead of keep computing the eigenvalue within the directive with a real value, you actually just call that utility. So that's going to be the change to happen, is that you're going to, instead of writing the code to compute the eigenvalue within your directive, you call that utility. That's going to be the main difference. But then you can keep your directive as is, I guess.
So that means I have to call the utilities 2 times? One for estimate the eigenvalue for the gravity, another for the mag.
Yeah, exactly. So for example, for the beta estimate right now, I call that utility twice. One for the eigenvalue of the data misfit, and then one time for the eigenvalue of the regularization, and then beta is based on the ratio of the two.
Okay, I see. Yeah, understand. I will check it. Thank you.
But yeah, ping me if you need help on that. As I remember, the way you wrote this directive, it was very close to the one before. So if you check the way it's written now, it should probably fairly straightforward to copy paste and modify to your need. I assume, but let me know if you have any issue.
Okay, got it. Thank you.
Thibaut, on that note, would you be willing to maybe on Xiaolong's pull request just create like a small sort of pseudocode snippet of where he needs to look, just to have those right pointers? Because you've got the map in your head, but that can be difficult to translate if somebody needs to go hunting around in the code. So if you could give the 5-6 line version, that might be helpful.
Sure, can do that.
Excellent.
Thibaut, is the math for all of this sort of captured someplace so that Xiaolong or anybody else could take a look and see exactly what is being done?
Well, yeah, it's the same maths as before, and in the documentation we say what we're using, that power iteration. But then we didn't copy paste like equation from the Wikipedia article or anything. So like there was no math description before, and there is no math description now really. Instead of we give the name of the method. That's I think what that is right now.
Yeah, in a lot of ways, Doug, what I'm working on right now in Discretize is kind of a test for making something similar on the SimPEG website. So when we're happy with theory sections for Discretize and we have all of that someplace, that becomes sort of a template for making theory sections for SimPEG.
Okay.
And that's sort of where the space, that's where my vision is. I don't know about everybody else, but
no, that actually sounds good.
Yeah.
Okay.
Excellent. Thanks, Xiaolong. Dieter.
Yes, I was mostly working with the automatic reading, sort of what I feared. So I released this automatic reading for CSEM, and then folks used it and it break apart everywhere. Mainly because they use it in different ways than I thought. So a PhD student is using it for up to 1 million hertz, very high frequencies, which is one thing I didn't really test because I never modeled it. Just because I thought in CSEM 1 meter cell width should be far enough for anything you ever do. But then it isn't if you go to really high frequencies. And the other problem was that the company, they tried to have a huge survey and then it ended up in some 150 million cells. And they had understandably some memory issue with that. Yeah, I had to do some changes to that code. And then I moved the GitHub org to another name because this EM-PyMod thing caused a lot of confusion. If one package is called like the org and the other package isn't, and then, yeah. So that one actually smoother than I expected, just some links to update, but otherwise moving GitHub repos not too hard. That was positive.
That's good. Thanks, Dieter. Sagi.
I have nothing really particular. I have found one good link from Carrie's webpage talking about how to understand the data uncertainty. So they actually wrote a paper about kind of doing a Taylor expansion and kind of how to assign the proper uncertainty in the frequency domain data. So yeah, it would be quite useful, like anybody working on any frequency domain data like an MT. So take a look at it. It actually looks pretty good.
Oh, cool.
Then I have no update.
That's fine. Pointing us to useful resources is a useful update. So thanks, Sagi.
Yeah,
Doug.
this new documentation is cool of Mare2DM. It's shaping up nicely.
Oh yeah, I hadn't actually looked at that.
Yeah, I just looked at that now. It does look nice. Got a nice feel to it. Yeah, I don't have anything particular to add. Excited to listen to Devin.
All right. Well, then we'll give the floor to Devin.
All right, a lot of pressure. Yeah. So I guess I'll just share the screen and give you guys the quick 10-minute tour. Let me know if you're hearing buzzing in the background. Apparently this neighborhood just loves to do landscaping at this time. But yeah, so what you're looking at now is the Discretize website. This is built locally on my machine. And there's two sections on the side here. There's tutorials, which we already have. And then there's the theory sections. And one thing you'll notice is that the sections in the theory correspond to a section in the tutorials. So I want these to work really well together. I want you to be able to look at the background theory about like what is a discretized curl operator. And then I want you to be able to go to a place where you can create it and play with it. And vice versa. If you're in a tutorial, you're playing around with stuff, you want to know how it works, I'd like you to be able to link back to the theory. So maybe we'll just go to operators or something. There'll be some kind of landing page. I'm really trying to assume that people don't have familiarity with this. So that base level of what is finite volume? What does it mean to discretize something? Where do things live? I am trying to start at a place where people maybe aren't as familiar. So you can link to the contents or associated tutorials if you want to. We look at, say, differential operators, and we build up the theory. So really based on what we have in the EM GeoSci, I spent a lot of time making images, and I'm sure I'll get some feedback on whether or not it makes sense or it's really getting the point across, but really trying to do a lot of visual aids, trying to keep notation really consistent. And if you want to, on any of these pages, there will be a place to link to the tutorial. So now I just got sent to a different place in the website. And now I'm in the tutorial section. And so now I can play around with going and taking some average in 1D, talking about mappings and dimension, you know, what do these sparse matrices look like, all that stuff. So I've done this for meshes, operators, so averaging, interpolation, differential. I have a whole host of all of the theory for taking inner products of different types, from basic to the tensor physical properties, differential operators, and now moved into the boundary conditions, how to implement boundary conditions on these differential operators. And then I have some examples of actually solving all this, so putting it all together. And so I have one for a Poisson equation where we choose to discretize on the nodes and then also at the cell centers. And so we derive it. We come up with some examples. We start with Maxwell's equations, or I guess in this case, Gauss's law of electrostatics. And we take the inner product and we talk about all of the different pieces that we learned and follow the derivation and get to the end. So you can see I'm trying to make a lot of use of these hyperlinks. When we define something, you can click on it and it'll send you to the theory page of what it is. So everything is all connected. And if you want to go to the tutorial, then we basically give you the final result, just a synopsis of everything, go through, and there's the discretized solution for one choice of discretization, and then we get basically the identical solution here. And in one case, the boundary conditions were natural. In another case, we actually had to implement them. And so that's generally the setup of what we have here. The latest thing I worked on is how we want to implement general boundary conditions on any of these operators. And I think I've got one way of implementing it. I think I could use another pair of eyes, but when we're happy with how we want to do that, then we can update the code to really just implement general boundary conditions on anything. So that's generally what I've been working on, and I think it's now kind of time to get reviewed. Do people like the notation? Do people like the figures? Does it make sense? Is there anything that people question is correct? It's always good to find any kind of typo in there if it exists. But that's basically it.
Oh, Devin, that looks really nice. Nice job.
Yeah, it's a lot of work for sure. That's good, man. You did great work.
Thank you.
Do we have somewhere where you can basically dump the built HTML folder so we can take a look around at it?
Yeah, that's kind of the next step. I know Doug was really interested in reading through it and giving his thoughts. So I was going to zip that and send it to him, but I'm open to any kind of feedback. So
I'm curious if we can like put it somewhere on SimPEG.xyz just as like a hidden index or something.
Yeah, we could easily do that. We could just like create a subdomain somewhere that's like temporary documentation or something like that to take a look at.
How much are you referencing back to the API, Dev? Because I think you're referencing a lot between tutorials and theory, but are we linking anything back to the actual code base?
Not right now, because I guess Joe has been working on how the API is generated and making lots of progress.
Yeah.
Yeah, but that shouldn't really be dependent on how you link to it. So you can like link to classes using that class, tensor mesh thing, and it'll create a link to the tensor mesh.
Yeah, I guess I didn't think about linking as much to the API
I think that's very important, right? Because that's why the SWIP-EDGE exists, is to present discretized. It's not like it's not a course. It's it's meant.
Well, it seems like it wants to wear a lot of hats. I mean, we need a theory section, and anything that you learn, you would like to be able to play around with. And then for any functionality that you have, you should be able to kind of call it, and then with a question mark or two, be able to go and get the doc string to spit something out. So I guess what specifically would I be like? I don't want to try and make links to the API with all the functions that I'm using. It seemed like that's, if you had a question about a particular function, you would just go to the API section of the website and find it, or you would call help and get it to spit out the doc string.
Yeah, usually, like, let's say like NumPy, it's the other way around, right? Let's say you're going to do a search on k-means. So you go to k-means, that's the API. And then after this, you can have links to like theory, examples, and all that stuff. But it's kind of the other way around. Like, you kind of like put the tutorials and the theory on top, and the API is kind of like hanging below, like with no link with it. But it should be the other way around. The API should be on top, and then the examples and tutorials should be underneath.
Yeah, and we can sort of bring it up to the top to sort of prioritize it a bit more. One thing that I did when I worked on some of the API stuff was you can create examples basically in the doc string, so that when you're in the API section and you're looking up a particular function, you get an example that's specific to that function. So those examples where you're just trying to demonstrate the use or implementation of a particular function, those exist, and those exist embedded in the API. So I guess it's kind of a slave to both masters, but I do see your point.
If you're like, okay, well, let's build a tensor mesh, you can literally like make that word tensor mesh link to the tensor mesh documentation, like the API documentation. There's no sense to like, if you find yourself talking about a class, you should like just make it a link.
Yeah.
Or something like, yeah, if you're talking about a function, okay, let's use the plot whatever, or we're going to use this utility function to do this or something. I could just make it a link. It's about all you have to really do as far as like the theory and the tutorials. You can put it all right in there with the RST.
One other question that comes to mind is also external references, as we can connect like a bibliography to the documentation, and it would be great. I dropped a link for the pixels and their neighbors that Rowan led the tutorial, which is a nice tutorial on finite volume. There's Eldad's book. There's other resources out there that we should be pointing to, because a lot of this, we didn't invent finite volume, so it would be good to point to other useful resources out there. I don't know, Devin, if that's something you've kind of been thinking through as writing this, because there's also like Uri Asher and Hen's work, like their textbooks too, that would be good to point to, because we don't want to end up like on the hook for really explaining every detail of finite volume. We should be able to point folks other places.
Yeah, I guess I don't want to go through the trouble of embedding tons and tons of references in the text, but I think up front we could maybe do something that says, this work has been adapted from the works of these people, see these books for a full treatment of finite volume. I mean, the goal is, if somebody comes into this and they're told, oh yeah, there's this great package, you should use it to build your project, or I want to use it to build your project. Be good if they just know what is actually happening and what they're doing, be able to get up and running as quickly as possible, and just be able to know exactly what all the available functionality is. So I
Yeah,
think
those are all fair points, but I
Yeah.
think also, I mean, this is an academic project, and it's important in an academic space to show that you are building on other people's ideas. These are not all our own ideas.
Oh, very
So
true.
I think that having that a part of the theory section is actually pretty important. I don't know. I saw Dieter nodding. I don't know if you have other thoughts on this too.
No, I didn't realize. Is it just there is no reference section at all in the docs at the moment?
Not right now, but that's something that I think we should hook up.
Yeah.
I think
Yeah, I guess
it's nice because if you have a reference section in the Sphinx, you can link to the same references from your doc strings of Python and in your theory, and you can have one combined reference list.
Yeah, we've done that with some of our other websites. Yeah, I guess it sounds like people really want to embed the specific references for each specific thing in the text. It's just quicker if we just take the things that we have used and it's all sort of upfront and says everything after this has been adapted from these
because we cannot grow if we do this, right? We cannot start appending new stuff. I think if you look at the scikit-learn website, it's really well laid out. Each theory section has its own references, its own link to its own papers. I really like this. I think it's something that we should emulate, and there's really good cross-reference between the API and the tutorials and the examples, and they all back click. So I think we should try to emulate this.
Okay. Well, I guess we'll find a way to package what I have now so that I can get feedback, and then whoever wants to be involved in that, we can just summarize all of the sort of changes that we think maybe need to get made, and when we come to consensus, we can I can make the changes.
That sounds great, Devin. Do you have a pull request started with this? Even just a work in progress pull request?
I was going to do that today if we were sort of happy with the current state of it. So
perfect. Yeah. That can sort of be the touch point for ideas and documenting things. Yeah, excellent. But this is really exciting to see, Devin. I think that this is really going to elevate the utility of the documentation and all, ease so many of those questions that we get around why different operators are used in different places. And so this is a really important contribution. So congrats on all your hard work on this.
Well, got to push it across the finish line, but thanks.
Excellent. Perfect. Does anyone else have any other items, comments, questions?
For those interested, BCGS is doing a special issue on airborne surveys over superconductor targets through MTNet. So check it out tomorrow at 4:30 BC time. I'll be the moderator, but James McNay and others will be there.
Excellent. Perfect. Okay. Well, thanks everyone. Have a good afternoon. We'll see you tomorrow if you're able to join, and if not, next week.
See you tomorrow.
See you.